So hey friends, welcome back to the channel, and in this video let's discuss about load balancer. So in our previous video we had discussed about how we can use horizontal scaling in our practical use to scale our application for many users because vertical scaling is impractical. Now let's discuss what will happen if our application is used by many users, but we don't have a load balancer. So in this case, what will happen is when user is going to access our application, it will be sending request to web server using the IP address, which in turn will send a request to our multiple servers. Now in this case, what can happen is a single point of failure. So let's say most of the requests are sent to our server 1, and if this server 1 goes offline because of some reasons, then this is a single point of failure, and we won't be able to send anything to the user. So this is basically our application will go down. So second is the overloaded servers can cause a problem. So in this case, let's say we have 4 services. Rather than getting each server one request, we are sending most of the request to one server, and hence server 1 can become overloaded, and server 1 cannot handle these many requests, and this is another problem. Next is scalability. Let's say more users are using our application and we want to add more servers here like S5 or S6, but we won't be able to do that because distributing this traffic without a load balancer could be a tricky part, and most of the time maybe we couldn't do that as well. So to resolve all these problems, we have a load balancer in place. Now what are the pros of load balancer? So first is obviously we are going to distribute our request to multiple servers in a orderly manner. Second is we'll have high reliability, which is if one of our server goes down, the request that is sent to S4 will be redirected to one of the healthy servers. Third is the scalability. So we can easily add more servers here, S5 and 6, and everything is going to be taken care by the load balancer to how to distribute the incoming traffic. And fourth is the optimization. So load balancer is going to take care of everything, like how the resources are used and to use server capacity efficiently and optimize for the bottleneck. Now the question is where we can add the load balancer. So there's no specific answer to that. It depends on the system and what are the requirements. But in our case here, we can have a load balancer where we are getting the traffic from the user to our web servers, and the other place where we can have a load balancer is right here when we are sending requests to our database. Let's say we are scaling our database into different uh, into different databases. There we can use a load balancer to communicate to different databases. Also, one thing to consider is when user is communicating through a public IP address, he won't be directly contacting our web server. Rather, now it will be directly contacting our load balancer, and then our load balancer we use private IP address to connect with different servers that we have. So these private address are used to communicate between the servers, and these cannot be accessed through the internet using these private addresses. So this was on the higher level what were load balancer. In the next video we'll be talking about how we can replicate data and how we can have more scalability and reliability on our database tier. So that's it for today. See you in the next one.